So we try to bin, and at binning, we bin it to the age, and after binning it, we have to include that particular column in our data frame. You already know how to bin. So this is how to put it to the data frame. Then when we run it, definitely there should be additional column that will be age categories. So after we run this, by the time you go and check the F, at the end of that behave, there should be something like age categories that we have just curated. So this is easier. It's easier to explain this. To explain that from 1 to 20 years, from 21 to 40 years, from 41 to 60 years, like that, and above 80. So if we have to plot this, it's going to be very easy to plot and to explain. So that was why we tried to bin that. After binning, then we also try to check again the info of everything. And when we check the .info, we discover that some of them, they are objects, some of them, and the age has become a category instead of object. Of course, you can turn it to object if you like. Of course, you know how to convert from one data type to another. So if you like, you can change it to category, but you can change it to object, but it's not necessary. Categories and objects, they are the same. So you can just assume the categories and objects to be the same. So now after that, we look into that. Okay, some of them are good at the what they have. Age is good as an int. Object is good. Job is good as object. Marital is good at object, like that. We discover that everything seems good. So now the next thing we want to do, we want to check the statistic of the object and categories using .describe. So when we run the .describe, we check that the job, there are 12 unique values under the job, and which the top out of them, about 932 contains blue collar. So, and about the marital, we have 3 unique values of marital, which 27,214 being married. Of course, we have others who may be single and widow or whatever. So, and the type of education like that, we check. Now, we actually want to know what are all these things under every one of them. So we started taking them one after the other. The first thing we took, we're still looking into, like, let's see those that are continuous and those that are categorical. So we check, if you do it like this on our data set, we are going to have fully things that are categorical and those that are continuous. So if we run this, we're going to see that some of our data are continuous, some of our data are categorical. We can check if we like. If I just only call this categorical, it's going to give me those ones that are only categorical. So which are age, balance, day, duration, campaign, day, previous. Those are the only ones that are continuous, that are continuous. And of course, the other ones are categorical. If you call this the categoricals, if I copy it, it's going to give me everything I've explained earlier. Everything I've explained earlier under my categorical and object. So it's going to bring them out that all of them are the ones that are categorical. Job, marital, education, and even the age group that we have just created has now become categorical, because under the categorical we have both object and categorical. So these are now with the continuous. The only problem we have here was the age, because we don't want to work with the age, and we have converted it to age category. So I don't think we have any other problem on the continuous, but now we have problem with the categorical. From the job to age category, all of them, they are categorical or they are object. But if we are trying to build a model will not be good if some models rather will not perform well when they are working with categorical or object. We have to convert them back to numbers. We have to convert them back to numbers. And that was the task that was given to us, that, okay, we have converted some of them. Okay, this is just to check again. Our behave is nothing. So, of course, the only thing that has changed in our behave is that the column has increased to 18 because of the age category we just created. So nothing changed. Now we want to be taking them one after the other. And the first one was the job, because if you check under our categorical that we want to be dealing with, we have all of these. We copy them one after the other. We are going to deal with the job, marital, education, default, housing, loan, contract, months, and payout, pay outcome. Why? We may not necessarily have to deal with the why because it's yes or no. But if we like, we can still, okay, yeah, since it's yes or no, we still have to deal with it because we want a good model. We want a good model. So some model will work well, some will not work well with categorical. So that is the reason why we are changing them. We are thinking to change them to numerical. But at the end, this is going to be the duty, major thing we are going to do. We are going to build a model that will work on all these things before we change it to numerical and check the performance. After that, we now build another model using the same model, but this time around, we are not going to work with this categorical. We are going to work with the modified columns. So that is going to prove to us that some models don't perform well on categorical. They only perform well on numerical. So we are going to use that to test. So, but let's create our table first before we begin to build the model. Now, what we did here was that we took the job and we checked all the values under the job. Of course, initially, we already see that under the job, we have blue collar job that has the highest. Of course, you can see here is 9732. After that, we have the management that follows 945 and like that. We don't want our model to be saying management, blue collar, technician, admin. We want a model that we say 1, which will represent blue collar, 2, which will represent management, 3, which will represent technician and like that. And that was why we map all these. We just copy and map it. So this is how to map. We map it. After mapping, we create another column that is named.
Make sure say the Friday or don't sleep with below them.
Hello, are we there? Hello, everyone.
Yeah, well, yeah.
Okay. So we have to map, and when we map again, we want another column, the way we did for the age category, we want another column that will be called job mapped. Job mapped. So job mapped, rather. So job mapped. So from the mapping, one, we are creating it from the job and the job mapping, and we want to call it a job map. We created that again. So after creating that, so what went wrong? Maybe I didn't run the previous one. Yeah, I didn't run this previous one. You can't jump. Okay, I didn't even run this. Okay, I've run this. Yeah, now I have to run this. If I don't run this, there is no way it will create anything. Now I can now say curate. It will now recognize. Okay, now I've mapped it. So if we check on our data frame again, the data frame will have contained something like a job map. We want to do that to our marital. So we did the same thing to the marital. We map the marital, we check the marital, and marital contain like 3, like married, single, and divorce. And we want to say married to be 1, single to be 2, divorce to be 3. But I think it should have even be single to be 1. But it's the same. Anyhow, we love it. But I think I would prefer single to be 1, married to be 2, and divorce to be 3. Since we have run it like this before, no problem. You are the one that designed it the way you want. If you want to explain this one to anybody, you have to give those keys and say anywhere under married where you see 1, it represents married. Where you see 2, it represents or in fact, if you like, we could have said 0, 1, 2. Yeah. If we like, we could have said 0. Okay. Let married be 1. Let 0 be single, and then if we say 0 is single, and then 2 maybe divorce is 2. It's still the same. So you are the one to say this is how it is. It's good to say 0 is single. So let's run it that way. So now anytime we check for, okay, we map it and we call it married map. That is going to be created again. I don't want to be reoccurring. I don't want a reoccurrence the F. So don't let us run the F yet. So now the same thing. Let me cut off these ones. Now, let me cut off this one. We have run all these earlier. Okay. Now, the next thing is the other ones we have dealt with married, we have dealt with job. The next thing we want to deal with is education. Of course, if you go back and check, you will see what we are dealing with. We are dealing with all these. We are dealt with job, we are dealt with marital. The next thing is education. After education, we are going to deal with the divorce. After that, we are going to deal with housing, loan, contracts, and like that. Let me copy in case if I forget anyone, I can easily just paste and see if we have dealt with everyone. So we have dealt with job, we have dealt with marital. The next thing is education. So we want to deal with education, and exactly if I copy this one off, I've not run it. This was where the assignment I gave to us starts from. Yeah. So and this is what was I was expecting everyone to do. So I didn't do it myself. I only laid the template, believing that everyone has done that. So this is the first thing you should do. You should do for education as well. So when you run the count for education, this is the count for education. After running the count for education, the next thing you are going to do, you are going to map the education. So which I've not done. So secondary, tertiary, primary, and unknown. So let me copy it and let's run it inside these libraries to map it. Okay, if I do it this way, anyhow I do it, it's the same. It's just to create the dictionary. After creating the dictionary, I have to put comma at the back of everything. Comma. Okay, the last one does not necessarily have to have comma. I have to have a column. Oh, I'm using semicolon. Column. All of them are supposed to have a column because it's a dictionary that we are using in mapping. Column, and then this data string, we have to make them to become string. This is a string. This is a string. All right, this is also a string. So it is now left for us to say the one that will be 0. Let me use unknown to be 0. Yeah. Primary to be 1. Secondary to be 2. I think it's commonsensical this way. And tertiary to be 3. Right? So you could have done it maybe 1, 2, 3, 4, or you could have said 0, 1, 2. It doesn't matter. Anyhow you do it, just you are just sure that anytime you want to explain this, you have to explain what each of these alphabets mean. So it's a domain variable. You are the one that determine that tells what they have. So after that, after mapping it, the next thing is to I will run the map. So after running the map, I have to curate the data frame that contains the mapping. I've already done that. So it's just to run it. So I'm sure now that my data frame will contain married. Oh, it's not married, it's education. There is a problem now. I will be having under my data frame, I will be having 2 married. Because if I run this, that doesn't mean it's still going to curate. Later, I will remove that. Let me curate it. So it has been curated. Let me check. It will be creating 2 married because I made mistake. So now it will be creating 2 married. Let's go and remove the other married, the egg. Let's run. Okay. Now let's go here. I have, okay, age category, job mapped, married mapped. Okay, it has replaced the former married map with this new one. So, okay, since it's the same, let me go and rerun that so that it will be different. I will go and rerun, okay, this married. Let me rerun this married, rerun this one, and rerun this name so that it's going to replace all the values. Now let me now rerun this. If I run this one now, I think it should be corrected now. Okay, you can see married and education, they are no more the same. Initially, married and education was the same because I run it twice, okay? 1 means married, 0 means single. If I see 2 now, it's going to mean divorce. Okay, this 2 means divorce, means this individual is a divorced fellow. So that is that. I've learned this. So now the next thing is to curate for the default. Just ensure we don't make the mistake of married again. It's going to be default, okay? Now, under that, we want to run the mapping. Before then, we have to run this one to know the unique values under the default. Maybe I think okay, yes, and no. This one is easier to map. So under the map, we are going to say yes. We represent okay. Let's just say no. We represent 0, and yes, we represent 1. Yes, we represent 1. Of course, there is no total value. This is the map. Okay, we have been able to map again. And let me just copy this away. I only make that to make everything easier when we come to class. So I think it's better. Okay, I run. Now, after running, let me curate the data frame. This time around, default, okay, mapped, okay? I don't want to run married again. Okay, good. So after this, the next thing is the housing. Yeah, we have the housing. We are going to run the count for housing again. I've laid down my code before, so it's easier for me to just copy. Okay, for housing, they said if I run for the housing, okay, it's just yes and no as well. So let's no, let me always run no equals to 0. It's the same, whether you run yes first, it's the same. Just make sure and yes is equals to 1. I just want to be consistent. So I don't need this. So this is easier now. You don't need this comma. So this one, let me copy. Okay, if I run this, it's going to create the map. Then after that, I want to create for housing the F containing housing. So after that, again, I have another one, which is loan. I want to work on the loan. This is on the loan. And on the loan, I want to check the count. Oh, you see yes and no, no and yes. Let the first one be no. That's a 0. Yes. That is 1. Please, I hope we understand everything I'm doing. Hello, everyone. Hello, are we there?
Yes, following.
Okay, so I run this. After running the loan, I run again. You know, occasionally we can check the head. We can be checking the head, make it be, we can just check the head.add to see if .add, if everything is going well. Because just to check, of course, it's going to work, but of course, you just have to check occasionally. We can check again and say, let's see everything we have been curating. Okay, we have curated job, married, education, default, housing, and loan. Now we are done with loan. Then the next one after loan is contacts. So let's check what is under contact. I don't even know what's gonna be there. So maybe through phone, through email, I don't know. But let's check the unique values and the account. So we check, okay, cellular, unknown, telephone, good. They are just 3. So we could have said under cellular, maybe if we like, since this one is not ordered, we can say cellular is 1, unknown, maybe telephone is 2, is 2. Yeah, I'm not decided not to start from 0. And unknown, okay, I can use unknown as 0. Yeah, I can use unknown if I want to start from 0. If it is unknown, it is sensible to say 0. call it 0. Okay. So if I run it this way, I create sorry, my hand mistakenly create empty text, and I don't want it. Okay. Okay, let me run it. After running that, let me create the data frame of okay, contacts. Okay, yeah, good. So the contact has been created again. So the next one is a month. Yeah, the month is going to be ordered. Yeah, everybody knows that month is ordered from January to February, and it's going to be good if you say January is 1, February is 2, so since ordered, so it's going to be good. So it's going to be sensible. Everyone knows that month should be okay. If I don't want to stress myself, I can just copy it as well. Just copy. If I copy it, I come to the map. This is where I want to map it. I go down. I curate it as this. Then I'm going to do the same stretch. Let me just copy this one away from them for now. Put it in another column separate. Another separate column. Okay, and now starts my mapping. So if this is my mapping, there should be column for all of them. It's interesting. It's very interesting to do all this. Easy to map. Oh, I make mistake. The next thing is to ensure that all of them, they are in brackets. Okay, I put comma in all of them. Except the last one. Even if I put it at the last one, it makes no meaning. It's not going to affect anything, whether I put it or not. So I prefer to just copy and paste, because if I'm to define my own, I may mistakenly put some capital letter somewhere. I may not, like April, I may not put my April like this, and it's not going to match with what we have in the data. So later we may now change them if we want. We can still map it again. We can first map them to what we want to change them to, and remap again to a number. So depending. So now, but it's not necessary since we are even coding already. The first one is January, that will be 1. February, March, April, or May 5, June, July. Oh, okay, June is 6, July, August. Okay, September 9, October 10. Which one? November, okay. December 12th. So it's very commonsensical this way. So we run. So under month, anyone that just sees 1 already knows that it's January. So it's a common convention. If you use it otherwise, no problem, but it's not going to be a good convention to use. But there is no any restriction for that. But it is good when you see things that are conventional. You use them the way they are, so that anyone that sees the data will be, or immediately they see it, they understand what it means. So like this P outcome, I don't know what is going to be there. Let's run and see. Okay. Failure, order, sources, okay. Okay, let's see. Maybe when they were calling them, maybe the attempt to call them, in the data, they have already explained what all this thing means, but I've forgotten. Last week, we explored all of them. So if you still want to know, you can go back to the data on UCI, search for the bank, that bank, particular bank data, and then you will see all what this information means. So, but now, since I don't know, let me just map. We already explored it before, so mine is just to map. Okay, I can map it directly inside this unknown, failure. Can just do this. Next one, order. Oh, what happened? I created another orders. And okay, there is another third one. Let me just copy this to create the third one and put comma. Okay, that is success. So we may want to put failure as 0, maybe, I don't even know. I don't know what to. Sometimes things like this, I may just want to put it as failure and success. This unknown, failure and success, I don't know. The failure, others may be failure if it is not success. Unknown may be failure if it is not success, but we might just want to put it like 2. Like 2, if you like. We might just want to map everything. Anywhere you see unknown, map it as 0. Anywhere you see failure, map it as 0. Anywhere you see others, map it as 0. But anywhere you see success, map it as 1. I think that is the most important thing that concerns us. We want to see the success. But if we don't want to do it like that, we can go using the same format and say 0, 1, 2, 3, 4, 1, 2, 3, 4, like that. So it's good this way as well. But if we can reduce it, I may not really understand what I don't really like all these. I may just say, okay, everything is 0, 0, 0 if they are not success. So, but that one is just by choice. So there is no any rules for that. So it's just a choice. All this is just your way, the way you think mostly. So what you think it should be. So, but since we just think it should be 1, 2, 3, 4, so good. But again, as for me, I will just think every other one should be 0 except success. That should be 1. But let's put it this way. So let me run this to create the data frame. To create the column in the data frame. Now, again, you know, we have worked on the age categories before, right? Everyone?
Yes.
Now, but I have problem with that age categories is still categorical, right? And the aim of everything we are doing is whether categorical or object, we want to turn everything to numerical. It was numerical before, we make it to become categorical. And now we want to make it to go back to numerical. But this time around, the kind of numerical we want to make it go to is different from the former one. Now, the numerical here is going to be between 1 to 20 should be 1. Between 61 to 80 should be 2. Between, and like that. So, which we could have created it that way initially. We could have just done that initially. But I want us to know how to bin properly. There are 2 lessons we learned from this age group. Age group, we have been able to know how to bin between one age to another. We are able to know that. And at the same time, we still be able to map using the same age group. That is just the lesson. If not, I would have just done the binning directly to 0 and 1. But I want us to really learn a lot from that one. So the smallest one here is 1. Let this one be 1. 20, let it be 2. 40, let it be 3. 60, yeah, let it be 4. And of course, we have just only 5 categories, and let it be 5. 1, 2, 3, 4, 5. We have to put the column. We have to put our column. Let's put the columns. We have to put the comma. Okay, we can make it regular. So yeah, so we can put our comma. Oh, I was putting something else. I was making them to become string. I want to put comma. Where is comma? Okay, okay. Remind me. Now I want to put, since all these are string, I have to make them to be the string they are. Oh, what am I doing? Good. So we now have this map, the age. We map it. We already mapped the age now. Oh, I'm supposed to copy this one of that. Let me copy. Let me remap. Let me now bring this to curate. Yeah, so I can now check the F totally, the head. So this is all about our the It's not even the head.head. One thing that will change here, the head will still be the same thing, but the number of columns will have increased from 11. Initially, the number of columns was 11, I think. I can't remember. From the first, the head, when we first imported the head, the number of columns was 17 rather, okay? It was 17. And of course, this will still remain the same because we did not delete any of these, so this should still be the same. 4, 5, 2, 1, 1 rows and 17 columns. So, but now it will still be 4, 4, 5, 2, 1, 1 rows, but no more 17 columns because we have created lots of columns. So we go check that now. Okay, 4, 5, 2, 1, 1, 28 columns. We have created lots of columns from job mapped to marital to educational, divorce, housing, loan, contracts, months, mapped, and of course, the last one we did was the categorical age category mapped. But I think there was still one we're still thinking we want to map, right? We forgot that. That is the Y. We can still remember. There was one that was Y, the outcome. Yes, let's.
Yeah, why that which is your somewhere.
Yes, let's make it. Let's make it outcome. Let's just even call it outcome now. We forgot to do that. So let's say this time around we are checking for Y. I think it was just a small letter. Let's check, and let's check, of course, to be yes or no that we have under it. Under it, we have yes and no. So that is what we call the Y. So after that, let's just map it. We are going to map yes 0 and no, yes 1 and no as 0. So let me just copy anyone that have yes and no to do my mapping. I don't want to type yes or no. Oh, I'm going too far. Yeah, let me just copy this. So yes or no? Yes. Let me just copy. So this time I will just say Y map. Y map is yes and no. Then after the Y map, the next thing is to create the data frame. Just copy the data frame. You can see it's easier to copy and paste. Just copy the data frame. And this time around, this, I want to call it outcome. Let's just call it outcome. Outcome. Oh, I may see outcome. Let's call it outcome. So of course, we are taking the outcome from Y. And of course, we are taking this from Y mapping. Y mapping, yeah. So when we run, these features will have been created. So we can check the f.head. Okay. We run the f.head and we check. Yeah, the outcome now, we have the outcome, which will be 0, 0, and 1. If we check them all, we see 0 and 1, 0 and 1. That is the outcome. This ends our data engineering procedure. So the next thing now, after we have done the data engineering, we, of course, earlier, we could have done the cleaning. We have assumed we have done the cleaning. We have assumed we have done any necessary visualization. We think we want to visualize. And again, okay, we didn't even check whether we have what do you call it? Whether we have a duplicate. The only concern I think I may have here is if there is a duplicate. There may be a duplicate, a duplicated value, there may be. So how can we check if we have a duplicate in our data frame? How do we check that? Who is helping us? Hello, everyone. I'm with you. How do we check for our duplicates? Those are things we should know by now. We should easily be able to check our duplicates, and even sometimes we used to draw for it. You can still remember. So who is checking the duplicate for us? Hello, everyone. Someone should give us the code. I'm with you. Hello. Who is helping us? What is the code for checking for our duplicates? Who want to help? Hello, everyone. Oh. Are we there? Hello?
Here.
Yeah. Please, let's talk. Who is checking the duplicate for us? What are we using? We want to see if we actually have a duplicated value. Of course, we can check if we have an outlier. Those are things we should have been able to do by now. Of course, we can as well check if we have what do you call it? If we have an NA value, non-value. So how do we check for all these? That of duplicate, that of NA. Okay. Someone
Just
is
a
talking.
second.
Someone is talking. I just want us to run through the, of course, we know there is no NA, but let's check. What's
Assuming if we use duplicated, DF duplicated.
the have dot
Duplicated.
Okay. Dot sum.
Yeah.
Right? So if we run, we are going to know, oh, it's not even duplicated. So we have as many as what we have. So there is no duplicated value. Let's check for non-value. What should we do?
We can use df.isna.sum.
Dot what?
Isna.
I don't know the spelling again.
IS.
It's not.
Yeah.
Dot sum.
Dot sum.
Okay. And I run. Of course, there is none. We already know from our describe, etc. But I just want to, the normal thing we are supposed to check. I don't know why this is running forever. Oh, what is the problem now? It should be 0. So I don't know why. I don't know if that is going to be okay. I don't know. I don't know what went wrong. Okay. Oh yeah, this is it. All of them, they don't have any non-value of which we know already. Those created and even those we have initially, you can see there's no non-values. This ends our data engineering, EDA, and the cleaning and everything. The next thing we want to do is that we want to start building models. But before we can build a model, there is a particular libraries that we are supposed to know. sklan. sklan. You call it circuit. Circuit LAN. I don't know. Why is it, the spelling is running away? I don't know. So sklan, if you use this sklan, there are so many things that are present in this sklan. Let me just quickly itemize what you can do with sklan. It's a library on its own. You have to install the sklan the way we install pip install, pandas, pip install, matplotlib, pip install, sklan. Sometimes you see that it's going to, if you say scikit-learn, it may say it's deprecated. So we have to write scikit-learn, sklan. So, but this is a library that is used for model. There are so many things that are present in this particular sklan. Number one, we have different models there. There are models that are in the sklan. So in the sklan, you have a module that contains models. In the sklan, you have a module that is used for processing. It's used to process. Well, at the point we are going to process some of our data, we have problem with some of these data. Even after doing everything we think we want to do with them. For example, let's check this balance, for example. If you check the balance, you will see that if we are to draw the graph for this balance, okay, how do we draw the graph for a balance? How can we draw a graph for it? Which graph should we draw? Like a bar chart or a pie chart, histogram? One thing is that if you are plotting the graph for something that has a value of 2 and something that also has a value of 2,143, you will see that there is going to be a problem here. You see that those ones that are very small, you can even see a value of 1, right? And perhaps you even see a value of 0. If you plot this graph, you may not be able to see anything from the point of those that have 2, those that have 5, those that have something like 10. Because you can still, if you check very well, you may still see that some of these balance, some people may have 20,000 balance in their account. Some may have 10,000 balance in their account. And why some even have 29 balance in the account. If you are to plot this, some become insignificant. But we have to still use them. The best thing we can do to this particular balance is that we can process it. We process it, and so kind of the process we can do, we can make everything to be standardized. We standardize them. For example, we can standardize it between 0 and 1. Like every values will be made to run between 0 and 1. There are some that can be made to run between -1 to +1. So there are different methods of processing this kind of numerical data. So we are going to be talking about them. And the libraries that help to do that is the scikit-learn. So in scikit-learn, you can process some of your data. In scikit-learn, you have different models that are in the scikit-learn. The same scikit-learn contains some data, some data sets. There are some data sets that are present in the scikit-learn. There are some data sets. There are some common data sets that are already in the repository that are used for training purpose. That as someone that is building models, like machine learning models, you will be used to those data. Those are the data that will be, you don't need to go and download them. It's already present in the data set of a scikit-learn model. Example is the cancer data set. It's a popular one. The other one, the iris data set, is also a popular one. All of them are present in the what do you call it, in scikit-learn data. So they are already there. You don't even need to go and download them. You just call them directly from scikit-learn. It's going to import those things directly into your system without you going to download them on your system. So that is also present in this. Another thing that is also present in this scikit-learn, you can evaluate your metrics. Let me just say metrics. Yeah, metrics. There are different metrics that we use to evaluate our machine learning models. So, for example, you are building a model and for example, a classification model that you want to measure some of these metrics like accuracy. You can import it directly from scikit-learn. It is the scikit-learn that helps you to process this model. You want to split. Another thing that you can do with the scikit-learn, you want to split. You want to split your data. You can split your data from the models that is present in the module that is present in scikit-learn. It helps you to split your data. Split them into the test data and what do you call it? And test data, validation data, and training data. So all these are possible with scikit-learn. I have some of them summarized below. I've done that before coming to the class. We'll be using them. I will tell us how we use them. For example, these are the kind of models that we can import from the scikit-learn. From scikit-learn.scn import. This is a model on its own, a model. This model is used for classification. Some of the models are used for both classification and regression. So we can also import logistic regression from a linear model present in scikit-learn. We have this assembled. We can import random forest classifier from it. From this neighbors model, we can import KN classifier from it. From this, you can import. So these are all the models, some of the models, not all. Yeah, these are some of the models that are present in scikit-learn. Those models are what we use to build our model. Okay. That is not the only way to build a model. Of course, the other time we were talking about TensorFlow. When there was a day we were looking through what do you call it? Through a particular all this stuff I downloaded, and I was showing us how we get different models, different way to model and things like that. So there is another one we call a neural network, okay, which this another way of building different models we like. And the other times we were talking about different models, that there are some models that are meant for images, there are some models that are meant for text, like natural language processing, and there are some models that are meant for tabular. All these are tabular model, like the one we are into now. All these models are used for them. Now, another thing I say we can do is that we can split our data using the libraries of this scikit-learn. And this is train test split. It helps us to split the data into train validation or train validation or testing data. So we are going to be using all this. Again, I said we have some metrics that we measure. For example, accuracy is the best one to understand. We measure our accuracy, how accurate the model is. You build your model is 70%, 70 something percent. You build your model is 60%. You build your model. This is the accuracy we are talking about. You import it from the scikit-learn. There are other type of metrics which we may not understand for now. Some of these metrics, like confusion matrix, is just like a chart, like a chart, yeah, that is divided, okay, depending on the kind of model you are dealing with. If it is a binary model, it's going to divide it into 4, classify some as true, false prediction, true prediction, and stuff like that. So that is confusion matrix. We have under the reports, we have sometimes we just call for the classification report. Under this classification report, you already have accuracy under it. You have log loss, you have recall, you have F1, you have precision. We also know we also have a matrix that is called precision. All of them, they have a different scenario they are best used. For example, if I'm dealing with a medical data, I don't like using accuracy. I love to use a recall. Recall is more used, is more important than accuracy when you are dealing with it. Even if you build a model that has a high accuracy and the recall is low, and I build another model that has a high recall and low accuracy, I will prefer the one with a low high recall and low accuracy, because of the kind of data that have to do with medical stuff. So all this, you just have to go and read about them, what they mean. You understand? This is a literature you can read. We have a lot of literature you can read on them, where they are best used. But all these are metrics that we can use to measure our model, how good the model is, the performance of our model. But if at all we don't understand any of these, we always understand accuracy, how accurate it is, the model is to predict whatever we are using it to predict. So that is the best known, the accuracy. That is the best known. All these are present in scikit-learn. Another one, I told you we can process with the scikit-learn. Some of the processing we can do with the scikit-learn, these are the one I love to use. There are other ones, and these are the one I actually know how to use. There are other ones I don't really care about them, but I use normalization, min-max scalar, label encoder, and standard scalar. Those are the type of processing you can do on your numerical data. You use them on your numerical data. You can use normal. Okay, this one can be label encoder, can be used on categorical. instead of the one how we are using mapping, we may not use mapping. Yeah, we have dealt with that before. We may not use mapping, we may just use a label encoder. I love to use mapping and label encoder as well. But we have used mapping, we don't need the label encoder. You just need to use one of them. Someone was asking the other time when we were using label encoder that can't we just program, and instead of calling this label encoder, someone asked, right? And I said we use mapping, and we have been using mapping all the way. But as well, if you don't want to use mapping, you can use label encoder. I love to use mapping because I can control what I want to call them. I want to call this, I want to call it 1. I want to call this one, I decided to call it 0. I can do that with my mapping. But like look at label encoder, we just take them and put whatever it's like by default and put it. But when it comes to the numerical, you can use normalization, you can use min-max, you can use standard scalars. Okay, so there is a way to do that. So later we will be using them one after the other, and we see the implications. Sometimes they are not necessary. Sometimes it is not necessary for you. You don't necessarily have to process your numerical data. Sometimes it is important to process. If you process, the performance will be high. Your accuracy will be high. Sometimes whether you process or you don't process, it doesn't matter. It depends on the data, and at the same time, it also depends on the type of the model you choose. If you like, you can choose SVLs, SVC. If you like, you can choose logistic regression. If you like, you can choose decision tree. If you like, you can choose anyone you like, any of the models. If you build a model with SVC and it's not performing well, go and use logistic regression and see. You can use this model and get something like 70%. And when you use this model instead, you can get like 75%. And you can come and use this and get something like 90%. And you can use this and go back to like 55%. So it depends on the model and the data. Some models perform well on some data, and why some, of course, you can see some are linear. You can see this is a linear model. So if the data is something that is linear, okay, it's going to perform well on it. Okay, decision trees has some data. If the relationship between the input, they are linear relationship, of course, there are models that perform well on linear. There are some models that perform well on non-linear relationship. If relationship between all your data are non-linear, then some of these models may perform best. So those are the reasons why the models perform better than each other. The types of the nature of your data, and sometimes the volume of your data. The volume of your data also affects your model. Okay, the volume of your data. And then at the same time, the kind of processing you do. Some of these don't need any processing. Whether you do processing with it or you don't use processing with them, they don't care. They are still going to perform well. Some of them, if you don't process your data, they are not going to perform well. Some even work on categorical data without even converting them to numerical. They will still perform well. Why some, if you don't convert them the way we have converted them, then they will not work well. So these are things you just have to play around all these models and one after the other, and try to understand what accuracy means. Apart from importing model from circuit-land, I found this. There is another libraries where you can import other models. So, for example, logistic regression. You have your logistic regression here, logistic regression under circuit-land, linear. We also have what we call interpret glass box. So we also have what is called glass box. In this glass box, there are other models that are present inside the glass box. Okay, these models like logistic regression, classification tree, explainable, boosting classifier, they are also present inside this glass box. Okay, this is another step entirely, which is another step ahead of this circuit-land. The only thing we can do here when it comes to circuit-land majorly, most of these what do you call it? Most of this model, they are not explainable. They are not explainable. There's what we call SAI. SAI. Okay, this is it. That's what we call SAI like this. SAI. Okay, this is explainable artificial intelligence. If you want to work with explainable artificial intelligence, that is another step ahead of the normal circuit-learn we know. In this explainable artificial intelligence, sometimes we can use interpret. There are models that help us to interpret our classification, our model. It's telling us that, okay, you, this model, predict this thing for me. If you have predicted it, okay, I have an apple, and I say, what is this? And the model says, oh, this is an apple. And the next question is that, why did you say it is an apple? Why not a mango? Or, okay, why not an orange? Yeah, why not an orange? Why an apple? If you bring a green apple and a green orange, and you are able to tell me that this is an apple, why not telling me that it's an orange? That is the question that everyone is asking a model. If you are a model and you are able to predict, you should tell me why you have predicted this particular thing to be. Okay, the model will now begin to explain, okay, when you turn it like this, it is curved at this place, and when you turn it like this, it has to do this. When you do it like this, it has that. So those are what SAI will do. SAI will help you to explain the reason behind the prediction. And common example of SAI is line, sharp, counterfactual. We have counterfactual. I don't even really get the spelling again. Counterfactual and etc. We have different type of explainability, which may be beyond our, because we may not really have time to go through explainability, except we're gonna have a time when we will have maybe a seminar through the body to let us organize a seminar on explainability. But before we can even begin to talk about explainability, we should be able to use all this model effectively. We have been able to build a good model. We have been able, in some cases, we have been able to interpret our model through through the metrics. We have been able to, in some cases, we have been able to normalize our data. And that's it. If you are able to do that, then the next thing we can now do is like, okay, now we have good model. We want to go for that to like interpret the model for us. That is when we can be talking about SAI, explainable artificial intelligence. So before we continue from building a model, okay, let's quickly rehearse to what we have done so far. Okay, everyone?
Yes.
So before we continue, I assume that so far so good. We understand CSV file. We understand even Excel file is the same. It's just to call CSV or to call Excel. We can download data from any repository now. We can do data wrangling on them. We can do some little visualization on them. We can do total cleaning on them, removing non-values, changing whether you want to remove, you want to change it, you want to remove duplicates. If you have maybe string number, we have special characters. Of course, you can know whether you have a special character if you call on dot values. If you call on dot values, if you call on that, it's going to bring unique values rather. It's going to bring the character as a unique value. For example, if I say under gender, I say male, female, and ash. Maybe someone mistakenly pressed ash or ash something under gender. Of course, the next thing you are going to do is going to be, okay, call for unique value under the gender. The gender will bring male, will bring female, and bring ash whatsoever they put, or maybe star, or even if it is a number combined with any other stuff. It's going to bring it out as the third one. And if you get it like that, you can remove it. You can just change it to something, or maybe you remove it, you can map it. You can just map it, okay, that ash, map it to become a female, or map it to become male, or something like that. Or you can remove that particular stuff. So it's easier for you to dictate using unique values. You can dictate any strange values and unmatch or match labelings. So this total complete data wrangling, I believe we can do them now. We can practice them. And of course, if you have some challenge, you can easily call on Google. You can call on your ChatGPT to help you out. The most important thing is that you understand what you are doing. You know what to use, what you are using. So I believe we can do that up to the point of cleaning all our data. After cleaning the data, we want to process some of these numerical. One of the processing we want to do with the numericals is that we want to bin some of our numerical like age into categories. Or maybe if you have something like height, for example, we measure the height of everybody in UK. You might like, oh, we have a continuous values, and I say, okay, I don't want to work with these continuous values. I want to bin them. Maybe very tall, dwarf, whatsoever the category we want to put them. Any category, so it's easier by binning. After that, if it is not a numerical that we are trying to bin, we can also try to, apart from binning stuff like that, we can also try to map and create another column for our categorical value variables to become a numerical values. Then once you have done all those stuff, all the pre-processing, the processing, the engineering and stuff like that, then the next thing is to start our model. And in the model, the first thing, when you know you want to build a model, you will know that we are going to use a library called a scikit-learn. It means you must have a scikit-learn installed on your system. I guess since we are using the Google Colabs is going to incorporate a scikit-learn. We don't even need to say people install scikit-learn. And if it doesn't, then we install it. So that is all what we have to do. And when you have your scikit-learn, we have established that there are lots of things we can do with our scikit-learn. At least I mentioned like 5. One of the things we can do with scikit-learn is that we can import some data set from scikit-learn. We can import some data set. The common data set that are on public repositories can be imported from data from scikit-learn. Another thing we can do, we can process some of our numerical or even numerical and categorical. If it is categorical, we can use encoding, label encoding to encode it instead of using of course, some of them we have used mapping on them. If we have not used mapping, we can use label encoding to encode them. But if it is numerical, most of the things we can do with numerical, if they have different range, we just want to ensure that, okay, let's all this numerical, no matter millions they have, no matter what millions, no matter what thousands they have, we only want them to be within 0 and 1. That is standardization in statistics. You can standardize them. And there are a lot of ways to do this. We can use min-max, we can use standardization, you can use a scalar. So you just import those libraries and use them on them. So the only thing is how to use them, which we are going to do. Another thing we can do in our scikit-learn, we have processed, is to import some of this model we want to use. If you have to look into what you are doing. If it is classification, you import any desired classification model you want to use. There are classification model, there are regression model, there are some models that are used for both classifications and regression. You can Google it and know more about that. Classification models, regression models. Of course, the other time I use a chart to explain to us those that are classification models and regression models. You can Google more to know more about classification models and regression models. And some of the models are used for both. Now you can get models from the scikit-learn. And another thing you can do from the scikit-learn is the evaluation, your metrics. And the most important, or well, I won't say the most important, the popular metrics is accuracy. You can import the model accuracy. You can import it from scikit-learn and use the accuracy to evaluate your model. And another thing you can do in scikit-learn is to split your data. You split the data into training data, test data, or even validation data. So those are one or two things you can do in your scikit-learn. It's a great library. Now, we know that we have various libraries we use as a scientist or an analyst. You use a NumPy, you use Matplotlib, you use Seaborn, you use Pandas, and you use scikit-learn. Those are the common libraries that we use. There are other libraries like Beautiful Soup and some very others interesting libraries, but of course you're gonna get used to them as you go on in this journey. So ask your question, then we can introduce ourselves to models today, build one model, one or two models if we like, and then next week we just try to after you build your model, you can try to adjust some of these parameters to see whether the model is going to perform well. So those are the things we will be doing next week. We are going to build models today, but next week we're going to modify the model and say, okay, if I build the model now and my model is 70%, how can I make this model to be 72%? What can I do? Okay, let me do this and see whether it's going to increase. Let me do this, whether it's going to decrease. One of the things you can do that affects our model is the volume of our data. For example, you are working with a model that has, okay, this is one, I had this from a professor, said if you are building a model, the least data you can use should be 100 multiplied by the number of the features you have. For example, if you are building a model that have 5 features, okay, it means the least data you can use, the least data that is good, that the data will be that will be good for that data, the least data we can use is going to be 100 times 5. That is 500. You must have at least 500 rows before the data can be used to build a model. For example, you want to build a model to know the IQ of a particular student. You want to build a model to predict the IQ of our students. And then part of the features we use is like the age of the student, the size of the students. Okay, you already have 2 features. Maybe you want to use the height of the students. You are having the 3 features. You want to use the maybe the race of the students. You're having the 4 features. And I don't know which other features you want to use. Maybe let's say you have 4. Although this is not going to be good enough to predict the IQ, but let's say you already have 4 features. It means if you are using it to predict an IQ of, you must use nothing less than 400 rows. You must get a data that is less than 400 rows before you can start to build the model. If you begin to add other things, like the social economy or economy stuff of the family, it's become 5. You added some other things, like maybe the parents are educated or not educated, that is 6. You added some other things, then you multiply those features by 100 to get the number of the least rows of data you can collect to do your experiment. These are stuff that affect the model performance. But for example, you need something like 1,000 data, and you need like something like 1,000 rows, and you will have a data that have like 5,000 rows, and all you need is just 1,000. Of course, the model is going to be good. The model will have the opportunity to learn a lot from different data. So the volume of your data is very, very important. It's very, very important. Of course, the noise in the data, that one has been taken care through cleaning. You clean your data very well. When you clean it, the noise, that one has been reduced. Okay, so please ask your question before we go to trying to build a model. Even if you can build one model today, it's easy to build a model. So So ask your question and let's continue. I'm listening. Hello, everyone.
Yes.
Yeah.
Abdul,
Yeah.
I'm trying to do the mapping for the month.
Okay.
But when I do, I am getting I don't know, it's giving me some float, and then some of the results are NAN.
NaN.
Yeah, I'm not sure what's happening.
Maybe for the month, maybe you were trying to name the month by yourself. You are typing Monday, January, February, right?
No,
You
I
are
just copied it. I copied them from the,
You copied.
yeah.
And then you ensure that there is no space between the brackets, the quote you use.
Oh,
Yeah, if there is a space, it's going to be seen as something else.
okay, that's what happened.
Yeah, and if there is a space. So when you copy, always ensure there is no space. Reduce the space. That will always be a problem.
All right, thank you.
Yeah, you're welcome. Okay, anyone ask a question before we start building? Okay, let's start. If there is no any other question. Shall we?
Yeah, we can proceed.
Okay, yeah. Okay, let me share the where am I going to share now? Okay. Yeah. I think I'm on. Where's my Google Chrome? Yeah, we are here. Okay, good. So you already understand what we can do with sklearn, right? Right?
Yes.
Yes, yes.
Okay, so now since I don't need it again, the next thing I have to talk about is the process, the procedure of building a model. So, okay, well, I can still leave this in case I want to share the collapse so that we will all, let me just make it a comment. Of course, you still remember this comments, multiple line comment. Okay, the next thing I want to do now is if we want to talk about steps for making for building a model. They are just simple steps that we just follow. So let me make it a long comment as well. Steps. Steps building a model. Don't mind me, sometimes my what do you call it? My spelling ability will just disappear. So I don't know why. No. Maybe the use of all these tools has spoiled someone's brain that you can hardly even remember when you immediately are typing the what do you call it? You're already telling you what the spelling should be, so we no more bother ourselves with spellings again. So to even write any stuff now becomes a problem. Start building a model. The number one step, I've just been thinking about it. The number one step we're gonna use is of course you already have your dehave. What we are going to do with this dehave is that you split your, I don't want to use the word split. You divide the is it divide that is good for it? Okay, define the features. Yeah, the features into two groups. Okay, what did I mean by this? It means there is going to be a group for F's, the inputs, and targets or output. Let me just say output. You are going to divide your data into two, your features into two, the input X and the output Y. Of course, the other one, we already put it as output, yes. So it means, the only thing now you have to know that your output is only one of the features that you're going to use as the output. It's only one of the features. Like from, if you check this, your def from here, if you said, you can see all it has how many columns? It has 20, how many columns do we have the other time? Okay, we can see it here. It has you can't see it though. It has about 28 columns, right? Or 29 columns. If it has this 29 column, only one of the columns will be used. Let me just call the head so that we can, let me call the head first so that we can understand what I'm saying. Before calling the .NO and stuff like that, let me just call the head here so that you can understand what I'm saying. You can see out of all these def, we have 29 columns. Okay, these columns is what I refer to as the features. Let me just copy so that anytime you hear the features, you already understand I'm talking about the columns. Yes, I think it's better that way. So divide the features or columns into two groups, the inputs and the output, X and Y. From the all columns, all these from each to down to what we call the outcome, only one of them that we are going to use as our Y. Unfortunately for us here, we also name it as outcome here. Sometimes, for example, if it were to be disease and the one we are using to predict disease, it can be something like diabetics. And you see under the diabetics, you see yes, no, yes, no. That is the outcome. That is the outcome of the people that has a diabetics. I hope you understand. So it's only one out of these features that will be used as the outcome. So now, if we have how many columns here? We have 29 columns. Only one of these will be used as Y. Every other one will be for the what? For the input. But it is not compulsory that it is everyone. I hope you get my grammar. It is not compulsory that it is everyone that is used as the outcome, but all as the input rather. All I know is that one of them, only one that will be used as output. The remaining 28 are used as input, but not all the 28. In some cases, it can be all the 28. In some cases, it can be 10 out of the 28. In some cases, it can be 15 out of the 28. In fact, it can be 20 out of the 28, depending. Right? So that is one. So you already know that we have the inputs and the output. You can get it. And someone will now ask, how am I going to get the output from the input? It's easier. It's just to drop. You drop one. You drop all of them except that one as Y. And you drop the Y and use the other one that you didn't drop as X. That is one. That is the first step. The second step, the next thing you are going to do after you drop the, what do you call it? The target after you get the target and the outcome and the what do you call it, the input and the output, the next thing you can do is to get the array of them. Let me put it as part of a step. Make them to be an array. An array. You know, they are going to be in a data frame. You know, they're going to be in a data frame that we have a row and column. We don't want that. We want to make them to be an array. That will not be they will no more be what do you call it? Rows and columns. When you make them an array, even by the time you look into it, you will even understand it again. It's going to be like a different data entirely. For example, let me make this an array. Of course, you can see, okay, let's see. We have seen what the F is now. I don't even want to split. I just want to make the F an array. You have seen the F. Let me just say the F. Let me just say the F dot values. Dot values. Dot values alone. Let me just say the F dot values alone and run. You will see what it's going to give me. See what it gives me. You can see that it's no more, you can see 58, management, married, 1, 2, 3. You can see that it's different from what I have here. You can see the only difference was just that I just say the F here, and I got this, a data frame. And down here, instead of saying the F again, I just say the F dot value. So it should still be the same thing, but you can see that they are not the same. In some cases, you won't even understand it again. You won't understand it again. You can see I only said the F dot values and see what I got. So you can see here it's already an array. It's no more a data frame. You can create an array from your data frame just simply by saying dot values. So you now understand what I mean by changing it to an array. So let me delete it. I don't need it again. Okay, that is what I mean by changes to an array. That is the second thing you do. When you change it to an array, number 3, sometimes you may, all this one I want to put, they are not compulsory. Even making it an array is not compulsory. Some, what do you call it? Some model will work well, whether you make it an array or not make it an array. So let me just put it in this and say not compulsory. If my compulsory is not correct, we will correct it. Thank you. It's not compulsory. Now, make them to be an array is not compulsory, but you should make them to be an array. The next thing you should do, sometimes I told you we have to do some processing. You process them. You process some of your data. Some of the processing you can do with your data is some of the processing you can do with your data. You can do min-max. You can do what do you call it? I listed them out the other time. You can do standardization. You can do. They are not compulsory. So again, let me say not compulsory. Normalize your data. Again, not compulsory. We may jump them. Not compulsory. Normalize your data. But apart from that, after dividing it into the features and you divide it into input and output, the next compulsory thing is that you must split your data. Split your data into training and testing. And testing sometimes, and validation, sometimes you can divide it into 3 groups, but majorly training and testing data set. So what is there is that your input will now be divided into 2. You can, for example, you assume everything is 100%. You can use 70% for training and use 30% for for testing. The same thing, immediately you do, the same thing will be applicable to this. 20% for 70% for training and 30% for testing. Majorly, we use some can say 85% for 85%. Some you can use 90%, depending. Okay, but it majorly range between sometimes 75, 80, 85. Those are the most used division. You may use 75%, 80%, 85%. If you like, you can use 90%. It's your choice. So it's your choice. So that is how to do this. You can split them into a training and a testing data set. After they have been splitted, which you have splitted into training and testing data set, the next thing you can do is to call the model you want to use. Because if you already says, okay, this is what I want to use. This is you have already divided them and do this, do that. Then the next thing you should do is that which model did you want to use? Which model? So you can call for your model. So the next step is to number 5. All this one, they are compulsory. Number 5 is to declare. Let me use this to declare. I think declare the model to use. Okay, which model do you want to use? Okay, I want to use logistic regression. Okay, you can. What I mean by declaring the model is that choose out of this common model, choose any one you want to use. You choose any one you want to use. Of course, if you are doing that, I forgot something. That should not be part of the steps. But let me put it as a general step. Import the necessary libraries. You import the necessary libraries, okay? So you must have a libraries you are using. SK, circuit line, LAN, this and that. You must import them. So if you like, you can import everything. You import all these, but sometimes your processing time will increase. So you can import everything and choose any one you want to use. But if you know you are only going to use logistic regression, just import just only this first one, the one I highlighted. If you know you are going to use this, just only import this one. But as well, you can import everything and use any one you like. So you declare the, what do you call it? The model to use. After you declare the model to use, number 6, the next thing is to fit the model. Fit the model like train the model. The model. After training the model, you evaluate your model. Evaluate the model. So you evaluate your model. So you fit the model. Then when you fit the model, fitting the model simply is just like you even before the evaluation, you are supposed to make prediction rather. So let's predict first before you even evaluate. You have to predict. Number 7, yeah, let's predict. You predict. You use the model to predict. So when you predict, you evaluate your prediction. So those are the steps. And later, when you are very good, you can, of course, you can deploy your model if you want. You can deploy model for use. Okay, you can deploy your model for use. You save your model, you deploy, and sometimes you can continue to do some other things on the model to ensure that you have a good model, a best model. Okay, so those are the things that are involved. Okay, let's start. We are going to follow the step one after the other, but we are going to drop this not compulsory normalization for now. those are things we are going to do in our next class. Okay, now we predict using a particular stuff, and then next time we now try to normalize and see whether it's going to perform better. But before anything, I want to copy the F2 is equals to the F dot copy. Let me see. Okay, let me check my DF2. Oh, I don't want to call it DF2. Let me call it okay, yeah, I can call it DF2. I don't think we have, okay, we have the F2 initially. Let me call it let me call it the F model. Yeah, let me call it the F model. Okay, I copy. Let me now call the F model. That is what I want to use to build my model. I don't want to do anything with my former DF. Okay, it's just a photocopy of the original this thing. This is what I want to use. This thing, I just want to leave that so that later we can go back and be referring to that in case we want to do some other thing. What I want to do first with this one, with this my DF model copy, is like I want to first get my DF and my target. That is my S. So how can I get my S from this? So what I will do, if I want to get, of course, we have a step to follow. The first step is to split, what do we call it? Is to split this into, what do we call it? We have to split it into both, please answer me, Joe. So we split it to both X and Y. Okay, we get our Y is equal to, let's assume that our Y is equal to the F model into outcome. We only need the outcome alone. Is the outcome that we want to call our output. Of course, the name it bears there is outcome. If you check very well, you will see that the outcome is what we call our Y. Our Y is the outcome. That is what we want to predict. Whether someone we kill to our, what do you call it? To our to the, what do you call it? To the campaign. We call it the outcome. So it's easier to get the outcome. So the outcome here is this. So if I run this, okay, of course I can check what the outcome is. The outcome will only give me the Y. That is my Y. That is my prediction. So if I say Y now and I run it, you can see that it's only the outcome. You can see it's only giving me 0, 0, 0, 1, 0, 0. It's all about the outcome. That is my Y. Okay. Of course, I don't need to do that. You already know how I got it. I only index the outcome out. But the next thing is that I also need my S. What is my S going to be? My S is going to be every other one that I will drop my Y. The F model, dot drop. Now, there are problems here now. Okay. So what am I dropping? Of course, I know I'm going to drop my Y, but Y is not going to be the only thing I will drop. Of course, I will set my axis. What is my axis going to be? Because we treated that axis is equal to 1. When anytime we are dropping like this, axis is equal to 1. Now, apart from what are the things that I want to use as my my S? So I can just copy this and see and use it. Let me just copy this. I want to be smarter here. Let me just copy this and use it to get things I will drop from the things I will not drop. This is all what we have in the data set. Please just look at the way I'm dropping it. These are all what I have. But of course, I don't need this. I I don't need that from my data set. I don't need it. It's already the Y. But some of these things, I have used them, like age. I don't need the age, okay? Because the age, I've used the age as age categories. And again, I don't need the age categories again, because the age categories is already the one that has been mapped as age days. Again, I don't need my Y, because the Y has been changed to outcome, which I don't need. Did I need P outcome? No, I don't need it. Did I need previous? Yes, I think I need previous because I have not changed anything like previous. Did I need campaign? I think I need campaign. Did I need P-Day? Yes, I think I need P-Day. Did I need duration? Did I change the duration here? No. Everything that I've changed before, I will just have to remove them. I've changed months. The month is already there. I will remove. What else? I in the housing, the loan, I think there was a loan, there was a contact. Let's see. Housing, loan, contact, months. I will have to remove them because I already have them. Housing, loan, contacts, and I've already done that of the month. Then what about the balance? I'm not sure. Yeah, I didn't change anything concerning balance. I think the next thing now is default education, married, and job. Default education, marriage, and job. So I don't need all these. These are the ones I need. Oh, those ones I removed should have been the one that will be in my drop. Okay, since I have dropped them and they are the one I'm supposed to copy and save somewhere and drop them, but since I forgot to do that, I can do something else. I can just go ahead and I can just go ahead and since those I'm supposed to drop, I've canceled them. It becomes difficult for me. I can just go ahead and put this one as my S. Yes, it's not necessarily I drop. I can as well index out. So I want to index this one out. It means I'm not going to use that other method I want to use initially. Okay. There are so many things we can do here now. I can just index this one out. These are the things I need. If these are the things I need, I can just index this out in my, instead of dropping. Yes, I'm not dropping again. I just want to model and index out since I forgot I did the opposite. So if I want to index out, what I will only do is that I will only copy all these and index them out. Okay. If I copy it, I copy them and put them here. Those are the things I need. Just the way I needed just one thing. I needed just only one thing here and I make it out. The same thing, I needed more. So I want to put them as a list. Oh, sorry. I will do this. Then put comma. Okay, I'm saying I want this in my S. I also want this in my S. But remember, no space. I also want this in my S. You know, it's opposite of what I wanted to do before, but you can either drop or you do it the way I'm doing. So these are the things I want. I index them out. This one is already having a space. So if I do it last way, it will give me error. So that is how I'm going to do everything. But another thing I could have done, I could have just dropped everything I don't need and work with that. So I'm just giving us different options. So I could have just dropped my data frame from the first place, just drop everything I think I don't need. As I'm adding, I'm dropping. I'm adding and dropping. Then I will now have the only thing I need. I will not have excess like I have now. But I don't want to drop them because I may have reasons to use the data again. These are the things I need in my data frame, in my S. These are the things I need. And honestly, this is the easiest part of once you get your S and Y, everything becomes easy. Very easy things to do. So I already get my S, and that's all. So if I get my S like this, let me run. If I run it, oh, what is the problem? I'm having a problem here. Unmatched string literal. Unmatched. Okay, there is another stuff here. Okay. Yeah, let me run again. Okay, I don't think, is there still, okay, there's still another one. I didn't cancel, okay. Oh, this one, I didn't put string on it. Yeah. Okay, let me run again. Oh, what is the problem? Let's just go down. Education, this, what happened? If we have a list, okay, maybe let me put it list of a list. If since it's not just only one, we now have a lot of the list. Let me put another one on it and see. Yeah, it runs because there are many. I put it as list of list. Okay, so now since I now have my S and Y, I can call on my Y now and run. You will see what Y will give me. This is my Y. My Y is only one column. So if I run my S now, the S is also going to be, okay, you can see, okay, these are all the S. You can see it's still balance, stuff like that. They are still in a data frame. Okay, so if I like now, I can continue to, I can jump the second step because I said the second step is not compulsory. The second step is what was the second step? And the second step is make them to be an array. So, and I said it's not compulsory, but of course I need it. Let me use it. Let me just make them an array. What I will only do to make it an array, I can just say S array if I like. If I like, I can still call it S, but if I like, I can just say S array and say it's equals to S dot values. Dot values. So the same thing, I can say Y array because I want to make them an array. Array is equals to, I'm naming it so that you know what I'm doing. Y dot values. So if I run it, if I print them again, I can print S array and Y array. It's not going to be in data frame again. Oh, what am I doing? Control C. Let me run S array and let's see. It's going to be different. You can see it's now different from normal S. You can see the S was still in a data frame form. And you can see if I run Y, it's still going to be the same. You can see array here. Okay, it's just to tell you what's the difference between when it is just in a data frame and when it has become an array. So we have this. Now, after we make it an array, the next step I say we should do is to normalize. But now I don't want us to normalize. In our next class, we're gonna normalize. The next one is to split your data into a training and a testing data set. But now, before we even do anything, all these things we are doing, all this we have here, we are supposed to run these libraries. Of course, we don't need any, the one I don't need, let me just remove them for now. I don't need this. I was only using it to explain. Let me remove this. I don't need it. We are supposed to run all these libraries and choose the model from them. This one should even be the first thing when we first, in fact, the first thing on our page here, when we call the import pandas, import all these, we are supposed to import all these things together with them. Let me just copy all these and go and paste them to the first place where they are supposed to be. Let me just copy and delete from here. So I've deleted everything. Let me go to initial page, this place, and go and run them there. Okay, let me just paste this here. These are all the libraries that I'm likely going to use. So if these are the library I'm likely going to use, if I run, okay, now it has run. It's in less than 1 minute, in less than 2 seconds. So since I've run them now, I can now begin to call for whatsoever libraries I want to call. So the next step is normalize. I don't want to normalize. The next thing is to split my data into a training and testing. And for me to do that, I must call a library which is split. I've already done that. This is it. This library is here. Scikit-learn, model selection, import, train, test, split. I've imported it initially. So I just have to use it now. Let me call for it and use it. I've called it. Let me just use it now. So those libraries, you must first import them before you can use them. And it is best practice to always import at the beginning of your page. So after that, the next thing I will do now is to split my data into train data set and what do you call it, and test data set. So how do we do that? You just say train. Let me just copy one of these things I have, okay, and use. Don't want to. All you are going to say S train, Y train, but we are not using S train. We call our S something else. We call it S what? S array and Y array. Yeah, that was what we are using. So S array, we are going to say S array. Oh, it's not. Let me type it directly for myself. S array. Yeah, this S array, comma. We get S array. We have Y array. Y array. That was the name we have. From where I was copying it from, I was sorry. S test and Y test. Sorry. We have S train, S train, S test, Y train, Y test. You now split a data from where? Which data? This is what I want to call for. The data of S, and that my S is S what? S array, and my Y array. Y array, that was what I call it here. And this is the test size I want to use. If I say 0.25%, 25, I'm saying you should use 25% for my test and use 75% for my training. That is what this implies. Once you see this place and test size, it's telling us that, okay, from use 75% for my training and use all these ones are default. You can just say Y train and S train, all this one are the first thing you can always put. S train, S test, Y train, Y test. You always call them like that. What we are saying is that use part of your S array as a training data set, part of them as a test data set, use part of the Y now as a train Y, and part of them as a test Y. It's almost like a default that we always put. It's almost like a default. But if you like, you can call it some other name. But it is better said to use the defaults like this. S train, Y train. I'm saying, look for take my S array. This my S array that we declared initially, split them into two, such that we are going to have some parts for training and some parts for testing. Again, also take my Y array, split them accordingly the way we have splitted the S, split them into two, and split them into S train in Y train and Y train and Y test. But if you are doing that, don't just divide them equally. Divide them in these formats. Divide them in the format of use 75% for training and 25% for testing. That is what this grammar means here. If you like, you can change this one to 0.20. If you like, you can change this to 0.30. If you like, you can change it to anything you want, but these are good ones. On random state, this random state, you can set it anyhow. Mostly, sometimes I use 45. Just use anything. You can use your random state anyhow you like. Choose them randomly. That is just a random state. Choose some random stuff randomly. If you have a large data, you can set it to like 100. I've set it, but let's use 45. If you like, you can. No, that one. This one is not compulsory. If you like, you set the random state as you want. So I set it to 25. Now that is the next thing you do. After you divide it like this, you run. You run it. It has been splitted now. You now have your S train, S test, Y train, and Y test. When you have this, after you have done that, the next thing I say you should do is to fix is to call for your model. Yes. Which model do you want to use? For example, we have many models that you can use. There are many models that can be used. So, and we have called a lot of this model. We have called for random forest. We have called for logistic regression. We have called for lots of these models. We are just going to use one out of this model. And the one you want to use is what you are going to declare and say, okay, I beg, use this for me. Please use that for me. And now what I want to use, depending on the one you think you want to use, for example, if you want to use logistic regression, we already have the logistic regression. We already call all of the common one. If you like, you can use logistic regression. If you like, you can use SPL, SPC. You can use random forest. If you like, you can use KN. If you like, you can use GNB. If you like, you can use the decision tree. Anyone you want to use there. The next thing you want to do now is to declare any one of them and say, it is you I want to use. Now, let's use as many as possible. Let's start with one. Let's start with maybe logistic regression. I want to say, okay, you call it anything you like, but let's just call it model. Let me call it model, or let me call it model 1 is equals to logistic. Oh, it's even suggesting logistic regression for me. Logistic regression. That is the one I want to use. So this is the logistic regression I want to use. So this is the first model I want to use. I run it. Okay. It's going to call for logistic regression. Now, okay, logistic regression, come around. You are the model we want to use. Now, after I call for logistic regression, I will now train, or most time, some people don't use model like this. They use the name of the model. For example, logistic regression, they just say LR. Yes, LR to mean logistic regression. Okay, they don't want to call it model. Or most cases, sometimes I used to say models _ logistic regression. That is the model _ I'm using logistic regression model. This one, you use anything you like. So maybe we should say logistic regression model like this, okay? This is the model I want to use, logistic regression model. After you declare the model, I say the next thing you can do, you have filtered your model, you declare the model you want to use. The next thing you are going to do is going to be to fit the model. You just say model.fit. Model, the model you declared just now. The name you call it is what you are going to use. Model logistic.fit. What are you fixing? You are going to fix S train and Y train. You always use the train to train. And what that means is that I want to train my model, Y train. Of course, you already have both your S train and Y train. This is where your S train you declare here. This is your S train and your Y train. These two are the one you are going to use to train your model. After you train your model, you are now going to use your S test to test the model. Okay, so if I run it now, it's going to train this model for me. Oh, what have I done? Okay, so and what you fit, depending on the name you call it. If I just call it model, I will just say model.fit. If I just call it LR, I will just say LR.fit. But since I call it model LR, I will say model_LR.fit and run it. It's training the model now. The model has been trained. You can see so fast. Okay, after training, it's now telling me that logistic regression, that is the model I just trained now, is logistic regression. After I train my model, then the next thing is to test my model. And how to, is to predict with my model. How to predict with my model, I can just call it Y predict. Of course, you need to predict your Y. It is the outcome you are predicting. You are going to use the model to predict a Y, an outcome. So you call it Y predict. Majorly, that is what's the conventional way you call it, Y predict or predict. Just call it anything. Y predict is equal to your model, the model you just trained, this model that just been trained, dot predict. There is a predict keyword that you can use, dot predict. What are you predicting? You are going to predict S frame. You are going to predict S. So you are now going to predict your S test rather, because you're gonna use the S test to predict for the Y. S test. S. I'm looking for S on my keyboard. S test here. Now I will go back and explain. Before I run this, let's go back to where we divided this thing so that we can understand better. This was what we did. We have S train. Let me copy it and put it here. We have Y train. Y train. And put it here. We are going to use S train and Y train to train our data. You know, out of this division, we still have S test and Y test left. What is happening is that immediately you take a data, for example, assuming it picks this first one as S train, you say, okay, look at this. So look at, as you are looking at this now, this one, the balance is this, the day is this, the duration is this, the campaign is this, and at the same time, at the end, it was under the outcome. What is the outcome going to be? Okay, it means we should use the old data to explain this. Okay, if you say at the end, see what was the outcome. You can see at the end, the outcome was 0. Okay, so okay, it means when the category was 3 and when the this thing was 1 and this thing was 5 and this is 0, okay, the outcome is 0. And see another one, no, when this is 3, this one is 1, this one is this is okay. When this one is 1, okay, this is what was studied in less than 1 minute when we were training our model. You look at the 75% of all the data, and okay, anytime I see anything that is like this, the outcome will be 0. Anytime I see anything that looks like this, the outcome will be 1. Okay, and look at them randomly like that. The 75% of the data. It remains the 25%. Out of the 25% of the data, you now say, okay, out of the 25% of the data, now take the one we want to use to test. Now take the test data. Your S test. Now we have talked about the train. Now take it remains the 25%. You didn't see that 25%. Those 25% were kept somewhere. So the 25%, they now went to bring the 25% and say, okay, out of this 25%, okay, look at this S. We now say, okay, I've seen something that look like this. If it is like this, and if it is the S is like this, of course, the Y is going to be this. You will now check the S and go and check the corresponding Y and see whether it's correct or not. It will do that for the remaining 25%. After, if you now look at it and say, okay, out of the 25%, you have been able to predict 25%, 20, maybe you are out of the 25%, you were able to predict 20% correctly. The remaining 5% was wrong. Oh, you are able to predict maybe 23% correctly out of the 25%, and then the remaining 2% was wrong. Okay, so that is what the model is doing. Now that we have built the model, we have trained the model, we now want to predict on X. I say, okay, predict, take the one that you have never seen before that you kept aside, the 25% you kept aside, bring anyone there, and let's see. Of course, the Y, we already know the Y, but let me see if I can guess the Y. They will keep the Y away and then use it to predict. So it will now predict, it has predicted. It will predict all of them. After predicting, then we want to say, okay, how many of them were you able to predict correctly? That is exactly what the model is doing. To know the one that has been predicted correctly now, we now have to call for the metrics. After predicting, we want to check the metrics and see out of this, which of the metrics, which of these have you predicted incorrectly? Let's see how accurate are you. That is when we are going to call on accuracy. So we now say, okay, you have predicted them, okay. The remaining 25% is what you have just predicted. Okay, let's see how accurate were you at predicting all these 25%. We now call for accuracy is equals to accuracy score, because we have already imported the accuracy score under the metrics. If you check, you are going to see that we have so many things we can see. You can see, we see accuracy score, we see confusion matrix, we see classification report, we can ask for all of these. But since the accuracy is the best thing that we can understand, let's just say, okay, tell us what's the accuracy out of the 25%, how accurate were you at predicting them? So that is the accuracy we are checking. So it's the same thing. You just keep copying the code. The only thing you just need is to split it. After splitting, it's the same thing throughout. So we say, okay, predict, you have predicted, okay, Y test against Y predict. Y test, the one we kept and the one we have predicted. Let's see the one that, if they match, then I will run. Okay, oh, what happened? Okay, we didn't call it Y prediction, we call it Y predict. You can see the name we use it matters a lot. So Y predict, okay, Y predict. We have been able to calculate the accuracy. The only thing we just need to do now is to print the accuracy. You can just say accuracy and see whatsoever is going to give us. 70%. Okay, this model calculated 88.89% accuracy. It was able to predict up to 88%. Let us say 89%. You can see. So now this is how good this model is. It's a good model if we can predict 89%. Another thing we can do, we can call for another model, because this was logistic. You use logistic regression. The assignment I will give now is that instead of using logistic regression for the model, go and build for other models. Go and use other models and see what their prediction is going to be. Our time has gone. This is where we are going to stop today. And we have been able to build a model that can predict up to 88%. Next time, we will also use the same model. The only thing we will do is to standardize some of the data to see whether it's going to predict better when we standardize the data. So this is where we are going to stop because of our time. Thank you. Yeah. Hello, everyone.
No, yeah, thank you very much for your time. It has been insightful. I appreciate it.
So we have assignment now. We just have to go and play with other models so that in our next class, we'll be able to just fine-tune and modify some of the data and see if we can get better. And another thing I will challenge us to do, we use those ones that are numerical. Those are the ones we use to train our model. Go back and use the initial data before we start binning, and use those ones to predict without binning, without converting them to numerical, and see how it's going to perform. So, and check the performance when you bin and when you use when you convert the categorical to numerical, and when you did not convert them. What I mean is that instead of using all this mapped, don't use those ones. Go and use the original one and see whether there will be an improvement. We got 88. We may get something like 70 because we are using categorical. you know where we are using them. It's going to be reading management, what is it, white collar job, all those jobs. Those are the things the model will be reading. But now it was reading 1, 2, 3. Okay, what about if it were to be reading all this white collar job? Is it going to still perform well? So try and see which one is going to be better. There are some models that will be better on when you convert. There are some models that whether you convert or you not convert, it's still going to be almost the same thing. They will still be able to predict well. So there are some models like this model now. If we go and standardize, we have not standardized all our numerical data. If we have standardized them, we may have up to like 90% or 90, sometimes you can have like 98%, can have up to 98% in prediction, which is good for our model. So that is how to determine whether standardization is going to be good for our model, is better than non-standardized. So you can practice so many things to see the difference between them. But this is just a simple way of building a model. Okay.
Okay, thank you. Yeah, I was just curious, because initially you said we are going to be continuing with using either Jupyter Lab or Visual Studio, but I just noticed we continue via the Google Colab instead of moving to Jupyter.
Yeah, we are using Google Colabs because for now, I have problem with my system. So I'm unable to, of course, my Visual Studio is working, but my the other one, I am unable to configure my Google Colabs, and rather my Jupyter Notebook. I was unable to, and I have been thinking I will have time. Honestly, I don't have time to configure them. Sometimes before I go, I remember I even have class on Saturday. Is going to still be on Saturday. Like, oh, I have class today. Let me quickly put 1 or 2 things together. So I don't really have time to configure it. But whether we use the Google Colab, whether we use Visual Studio, or we use Jupyter Notebook, is almost the same thing. But why I wanted to use Jupyter Notebook was because I only know how to use SQL in Jupyter Notebook. I don't know how to import my my SQL to my Google Colab. It's just a simple thing that I should just Google, but I don't have the time. But because I already know that of the Jupyter Notebook, I just want to use Jupyter Notebook to explain what do you call it, my SQL. So, but since I am unable to configure my SQL for my Jupyter Notebook for now, the best thing I should do is just to look for a way of importing my SQL to my Jupyter Notebook and to my Google Colab, but I don't have the time. That has been the problem. So whether we use Jupyter Notebook, Google Colab, or Visual Studio, is all the same. It's almost the same platform. It looks almost the same. Okay.
All right, thank you very much. Yeah, sometimes ago you said something about sharing the notes you are using in the class, but on the WhatsApp.
Yeah, I shared the last one. I think here. I downloaded it and I sent it immediately. And I said everyone should. You can remember, right?
You know, I wasn't in the class last
it was
week.
because we're not here. So
Okay,
the only thing I can do now is just to quickly download and share immediately. Because immediately I leave this place, I don't, most times, I don't remember I want to do anything again. So that I can upload, let me see if I can quickly download this so that you can play with this. Oh, save Jupyter Notebook.
Stop staying in German driving you do that. Look, it's back again. Stop jumping.
I'm coming. Okay, let me just download it immediately and send it so that there will be no question. Okay, this said the particular Jupyter Notebook, I've downloaded it, so I will share it now. Chat. Everybody, you go to your chat now. Download. Okay, this is the updated Jupyter Notebook. People that downloaded it last time, you can as well just re-download. We have all these new one for today in the Jupyter Notebook. So you have seen it? Hello?
Yes.
Yeah, so that's it. Because I may not even have the time to download again. So you can share with yourself, anyone that is not around, or you send it to the group. If I remember, I send it to Blaze. So yeah, thank you for your time. I think we call it a day. Any other?